Good morning. Good
morning. Good morning, everybody.
Good morning.
And
Good morning.
welcome to the webinar. Future of teleports and big data. It's my pleasure. I'm Martin Jarrod. I'm the Vice President for International Program Development with the GVF, and it's my great pleasure to welcome as guests on today's webinar. We have Hakan Savasan, Director for Research and Development with Profin, and Suleiman Kuzu, Director of Satellite Services Corporate Solutions with Turks. The organisation of this particular 50-minute session is that you will each commence with up to 10 minutes of opening remarks, and at the conclusion, ultimately half an hour. And I understand that the first opening remarks will be delivered by Profin, by Hakan Savasan. So Hakan, the next 10 minutes are yours.
Okay, thank you very much, Martin. First of all, again, hello to everyone. Let me start by introducing Profin. We are a ground systems integrator and ground equipment manufacturer. For 25 years, we are within the sector for the last 25 years. And in fact, we are R&D based ground equipment manufacturers nowadays. So let's start with the big data and how it has changed every year. And almost every appliance we own nowadays is a data producer and data consumer. Our cellular phones, our tablets, even our coffee machines in our kitchens are producing and consuming data. And it is inevitable that the satellite communications industry, which is nearly 50 years old, and the teleports, which is a very important part of it, will not be affected by this big data change. So I will try to explain the different dimensions of this change by conveying the technical side of the subject in the simplest possible way. While doing research on the subject before this webinar, I found out that the word big data is used for concepts related but different from each other in the satellite communication industry. For this reason, I would like to explain in general big data and three other very important concepts related to it. Big data is the name given to the data that can be used for different purposes, generally distributed and unstructured, which is too large in terms of petabytes or nowadays zettabytes to be stored in very conventional databases. And there are three basic characteristics that define the big data. The first one is it is really very large, which means the volume part of it. It changes rapidly its streaming data, so that is its velocity, and it comes in different structures, that is its variety. And nowadays there are a couple of more V's, but the big data is defined in three V's: volume, velocity, and variety. One of the related terms is the cloud computing technologies, which is very famous nowadays. These are computing services provided over the internet, usually over the internet, using computer resources such as processors, storage, network, and middleware, and/or end-user applications that are not managed and usually not owned by the user. Recently, it has been preferred by many institutions for its cost effectiveness and ease of management. There are different cloud computing models. These are public, private, hybrid, and community clouds. Big data analytics is another very important concept. It is the extraction of actionable insights from big data by using complex and advanced analysis models. When the next malfunction will occur in the system, which other products the customer will like, and whether the incoming email is spam can be easily understood with big data analytics. The last but not least one is the machine learning, which is very famous nowadays also. It's a branch of artificial intelligence, and it means that computer programs create their own information by extracting patterns from data. Computer programs can teach themselves to do everything I just mentioned when given large data sets itself. In traditional programming model, you program the algorithm, and then computer program does the same thing. But in that model, you give the data, and the program teaches itself. Usually it's good to have big data, but however, it cannot be used as a value-added asset unless it passes through the correct value chain to provide you meaningful, actionable insights. So you have to understand from big data to the intelligence how the chain goes, and you have to put the required mechanisms to do the right operations on the collected big data to get the most of the benefits you want from it. Data strategy is one of the other topics that you have to be aware of it, especially the teleports need to be aware of it. Because if you do not construct it correctly, you cannot get the big data. The first strategy category is to use big data to minimize your costs. Teleports can use data not only for their customers but also for themselves. It is possible to benefit from big data in order to reduce the initial investments and operating costs for teleports, to anticipate the malfunctions that will occur in the system, which we call predictive analytics and predictive maintenance, to eliminate sudden support of very large scale mission critical systems, and to manufacture ground equipment that will show better performance. The second category of strategy is when you and your customer use big data to make better business decisions. It is possible to make some decisions faster and more accurately based on big data to manage and direct business processes with business intelligence applications and to better understand your customer behaviors with big data analytics. The third category is the development of innovative products and services, making R&D processes, new products and services, and better customer experience designs based on big data, which can provide great advantages to teleport operators. Big data is a very big multi-layered technology. It's a very big layered technology. It starts with a sensor and actuator layer at the bottom, which is the layer where the big data is really created or transferred to the cloud computing structure via IoT gateways or directly from the sensors or actuators. Here, I would like to emphasize that the entire satellite ground station structure nowadays, including the RF chain, is located within the sensor and actuator layer, and cloud computing infrastructure, which consists of network, compute, storage, and service application layers, is commonly created in highly secure data centers with high availability. Microservice architectures like Docker, Kubernetes, or ecosystems such as Hadoop are used to provide customers with the best end user applications. If we talk about what are the end user verticals for the big data and the teleports, the enterprises, TV and media, telecom, energy, agriculture, and transportation industries are now and in the near future the biggest end user candidates for big data based services to be delivered by teleports. There are different service models for teleports, which can be examined under three different broad categories. These are software as a service, platform as a service, and infrastructure as a service, three main categories. I think everybody uses nowadays the software as a service. The end user uses the teleport operators applications running on the cloud infrastructure. Applications can usually be accessed from various client devices via a web browser, web-based email, for example, or a program interface. The end user does not manage or control the underlying cloud infrastructure, including the network, servers, operating systems, storage, and even individual application capabilities, except for their own limited specific application configuration settings. Platform as a service is the second service model. In this case, the end user runs applications created by using programming languages, libraries, services, and tools supported by the teleport operator on the cloud. In that case, usually end users write their own programs and services to manage their work. The end user does not manage or control underlying cloud infrastructure here, including the network, but has some limited control over servers, operating systems, storage, and applications. Infrastructure as a service, which we can give an example of the AWS, Amazon Web Services Gateway as a service. The end user can run software using compute, storage, networks, and operating systems provided by the teleport operator in the cloud. The end user does not manage or control the underlying cloud infrastructure, but has control over operating systems, storage, and deployed applications, and possibly some limited control of selected network components. As a conclusion, maybe 5 years ago, big data was a debatable phenomenon, but now it's a very tangible reality. So if the satellite communication industry and teleports accept this reality and embrace the technology change, they can continue their lives. But otherwise, they will lose their competitive advantage and eventually disappear. So this is a disruptive technology. We have to be aware of that. On the other hand, the entire ground station network infrastructure, including the RF chain, is virtualizing. This is very important. Teleports must quickly become familiar with emerging technologies such as software-defined networking, cloud services, virtual network functions, and adapt themselves to open technologies and best practices. Nowadays, running a teleport is just like a software business. So we have to adapt ourselves as a software business. The use of technology and solid technical infrastructure are necessary to make money, but they are not enough. So teleports have to create robust business cases to put user needs at the center of it and develop business models accordingly. As high cost, mission critical cyber physical systems, teleports are on the primary targets, one of the primary targets of cyber attacks. Since these attacks do not seem possible to stop, teleports should now be deployed as cyber resilient architectures. As the technical infrastructure and the services become virtual, the design, installation, and operation of the next generation teleports become more complex. So the operational agility and technical scalability of teleports should be addressed at the design stage. So I think this concludes my initial opening words. Thank you.
Thank you very much, Hakan. Now over to Suleiman with Turksat. The next 10 minutes of this webinar are for your opening remarks. Suleiman, over to you.
Turksat about the teleport and big data works, but of course, in our discussion with you in this panel, I'll be happy to how we wrote a sentence combining teleports and big data. In my briefly, I want to say about what is the Turksat position on future to develop the services and also how we can manage our big data. But I don't want to focusing on the processing and storaging of the big data. I want to talk about some which titles is collecting the big data in application of satellite cases, of course. And for Turksat, I can say Turksat is in satellite industry since 1978. And we have first teleport in Gölbaşı, Ankara. And as a Turksat was established in 2004 in satellite services, and it started in satellite services. But then we combined with IT services and cable services, and we are going on with as a 3 branches as a Turksat. Of course, these 3 branches give some advantages to Turksat to combining the services in most of the customer requirement. Turksat teleport the biggest one is in Gölbaşı, Ankara. There is KU band, VSS band, antennas in our teleport, and we set up systems and gateway systems head-end in our teleport, and also we have a data center in our facility for IT customers and satellite customers. Then also we have some diverse and gateway teleports in Izmir, one in Turkey, and in Cyprus, we have a head-end systems for giving the services to our customers. What is the data means in satellite services, near features, and how these parameters affect the teleports in the services from the satellites. I think the popular titles in satellite cases in near future is the mobility services, emergency services, sharing the resources, IoT, and 5G will be the most popular titles for satellite in our cases. And we have some investment in these titles in near future to giving different services to the customers, not only the traditional satellite services. Especially in 5P, we will focusing on the database services in different branches. We are investing on the IoT platform. We are investing on the 5G solutions. We are investing on emergency solutions, and also we are working with other operators to combining sharing resources and giving the global services to our customers. We want to reach everywhere on the world to give the Turksat solutions and services. On mobility side, our maritime service is ready and we have customers, and land mobile services will be ready up to end of this year, and the aviation is the next year in our network, in our roadmap. Our bigger corporations, the big corporations with international operators, Inmarsat was the first one. We are combining our resources, our capabilities to give the services in different areas, in aviation, maritime, and other global-based services. And also we combined the capacity with Avanti 2 years ago to give the services in Turkey huge bandwidth. Very shortly, I want to say about our IoT platform. We are now in this year we're testing the IoT platform in a test levels. But in 5P we will launch our IoT services with our own platform to the different area of the IoT with our ecosystem, with our branches. On 5G, we are to base it. We are developing our products, and we are working on the in R&D projects to give us some products in 5G side on the, with IMT operators. Of course, the big data will be composed of the data collected from these branches, and of course teleports will be a good points to collecting the data and store the data in the data centers in the teleports. And we are building our data center in our facility, and it will be finished up to this end of this year. And we use this infrastructure collecting the cloud services, all these applications in our sites. Briefly, I want to say on Turksat roadmap on this section, and we will discuss your questions for the teleports, big data, and other issues. Thank you, Martin.
Suleiman, thank you very much indeed. Thank you. Excellent opening bodies of opening remarks there. Okay, we have around about 25 minutes or so now to examine some key points to actually draw out various issues on which you have already touched this morning. Now, as you've indicated, more and more of the satellite industry's long-standing end-user customers like oil and gas and shipping, increasingly mining and farming, they're rapidly digitizing their internal commercial and industrial processes. That is to say, they want their remote IoT and other source data to be accessible from multiple locations and transmitted via perhaps big data analytics infrastructures onto decision-making centers. What, in more detail, does it actually mean for satellite? Does it mean for satellites that there is a much more elevated body of business to perform, services to perform for our customers? Suleiman, I'll let you go first.
Okay. There is a connection problem. I understand about a bit part of the questions. For the
Okay, I'll repeat it. Many of the satellite industry's customers are themselves rapidly digitizing their own processes. They want their IoT data, other data, that they can access it from multiple locations and transmit it onto decision-making centers. What does the increasing digitization of our customer base mean in terms of expanded business for the satellite industry?
Okay, thank you.
Yes, we do seem to have something of a connection problem. Gentlemen, it seems we've had something of a technology reset. Can you hear me?
I can hear you, Martin.
I cannot hear you clearly, I'm afraid. You are breaking up to me. Let me return to the question that I had posed before we had the reset. Many of the satellite industry's traditional customers are rapidly digitizing their own internal processes. For example, as we've touched upon already, they want their remote IoT data and other data to be accessible from multiple locations and transmitted onto decision-making centers, perhaps through big data analytics infrastructure. What does this mean for satellite in terms of potential growth and expansion of the satellite business? In as much as we are will be much more deeply involved in these customer digitization processes and the actual management of their data on their behalf. Suleiman, what do you think?
I think in IoT and similar type of multi-points applications is an exact opportunity for satellite industry. Why? Because for the management of the IoT remote points, the spread sub networks, LoRaWAN networks, and measurement points have to be managed central architectures. In satellite network structure is naturally a centralized network architecture. By this way, you can manage all the remote sites, spread points. These points can be called as a million connections maybe. And by satellites, you can manage and connect these points in one hop. This is a good advantage and providing an easy management of the multi-points by satellite systems. Of course, these connections have an advantage to create a private IP-based networks to the user sites. This is providing a security advantage also. This is spreaded multi-points industry, very advantages in satellite in a management side because there's a one-off connections by satellites as a summary.
Okay, thank you very much. Hakan, could I have your perspectives on this question, please?
Sure. I agree with Süleyman because Profen is a teleport operator also, so we know how difficult is and how costly is to operate a teleport. So by digitizing the data and giving the digital data services to our customers, we have a lot of opportunities, a lot of possibilities. Starting with the IoT and IIoT, for example, narrow S-band IoT connections, providing services for narrow S-band IoT connections, providing services for remote sensing, even the space situational awareness, and providing services related with the virtual network functions is very valuable. Will be very valuable for the digitized customers. On the other hand, just like the Amazon Web Services Gateway as a service, you can reduce the costs of the running a teleport, running a ground station, costs for a customer dramatically with using these virtualized ground networks. On the other hand, what I call network centric ground stations, you can gather all your ground stations together with these virtualized functions, and you can act many of your ground stations just like one, and you can give a lot of services, very cost-effective services to your clients. So I think the digitization of the client and the digitization of the data, including the, again, I have to say that RF chain, which we call the IF frequency, intermediate frequency digitization. By this means the location of the real antenna will be irrelevant with your services provided by your teleport, with your data center. Gives you a lot of opportunities for new businesses.
Okay, thank you very much. I'd like now to turn to the pairing, if you like, the balance between the teleport and the data center. Now, teleports on the one hand and data centers on the other used to be considered to be entirely separate and distinct infrastructure entities. Traditionally, teleports were 19-inch racks of hardware not having changed much in a 20 or so year period. But the trend that you've already indicated today, where teleports are increasingly becoming data centers increasingly becoming teleports. Which way round is it? Where will the primary continuing infrastructure, what form will it take? Albeit software influenced and software defined, but will we think of teleports becoming data centers as well, or will the data centers become the teleports, or doesn't it make any difference? Hakan.
Thank you very much for this question, Martin. Again, we are running a teleport, and in my opinion, I think that the teleports will become data centers in near future, because in our teleport we have a tier 3 plus data center which we are running, and everybody wants software defined things nowadays, because as the name implies, they are soft, they are reconfigurable. So software defined networking, software defined radio, software defined satellites, software defined whatever it is. So everything is virtualizing, and everything is going to software defined. So I think in the near future, the teleports will become data centers with very highly secure data centers, virtualized data centers, and the location will be relevant of the real antenna. So that's what I'm thinking.
Thank you. And Suleiman?
And as I said at the beginning, to writing a sentence with teleport and big data is a now maybe normal, but it was not normal maybe 10 years ago. But we can think about that. The convergence is a common lecture in industries, in markets. And the nature of the satellite, as I said, the teleport is a point for the flow of the traffic, and the whole traffic have to pass through from the teleports. And people saw that the data normally can be collected in these teleports. And it's only investing the data centers on the teleports to collecting the data and processing according to your aims. What is triggering to this convergence? At the beginning, reduction of the cost of the satellite connections trigger this point. People have this infrastructure, have this data, and after reduction of the cost of the bandwidth of the satellite, people investing their applications to collect these pass-through traffic in the data center.
We seem to have lost the audio connection again.
Yep.
Suleiman, can you hear me? No, I believe we've lost the audio connection again.
Martin, do you hear me?
Yes, I can hear you.
Okay, so it's related with the Suleiman's connection, I think.
Ah. Okay, perhaps whilst you're attempting to resolve that, Hakan, can you hear me?
Yes, Martin, loud and
Okay.
clear.
We'll continue until Suleiman's connection
Sure,
problem is resolved.
sure.
This is a continuation of the question to which you gave your answer on teleports and data centers. What kind of implications does it have for companies in terms of OPEX and CAPEX? Is the interrelationship changing, and is the emphasis on operating expenditure going upwards and capital expenditure going downwards? Is that the fundamental implication when it comes to the company's balance sheet?
Again, I have to say that within the 1 or 2 years, maybe not not long as 5 years. Running a teleport is just like running a software business. So I think that I'm not a business development guy or related with these business development issues, but I believe that it will affect both dimensions of it. For example, for the capex side, you have to invest other things in terms of softwares, in terms of networking, in terms of other equipment, etc. So the virtualization of the ground equipment, the virtualization of the ground station, and the digitization of the customer will bring new investments inevitably to teleport operators. On the other side, I know that running a cloud infrastructure for 7/24 is not an easy thing. It's not mechanical. It's pure software. So you have to invent the real resources, human resources, and computer resources to it. So it will affect the operational costs also, OPEX also, I think, as well.
Okay, thank you. Suleiman, can you now hear me? I think we still have a connection problem with Suleiman's location.
Yes.
We'll continue, Hakan, in hopes that
Okay.
the connection with Suleiman will be resolved. Now,
Hopefully.
this is perhaps a more appropriate question from your point of view as a research and development expert, rather than something on the business side. Now, I'm interested in really the next steps in data center evolution, and let me give you my background thoughts on this. Some satellites already function like mini data centers. They're receiving data from the Earth, processing it, storing it, transmitting it back to Earth. Now, of course, with LEO satellites, as well as the orbit itself giving latency advantages for time-sensitive applications, on these LEO systems, there's provision for in-orbit processing, storage, and transmission, and also things like resiliency, because there are so many nodes. What do you think about those comments of mine on the next stages in data center evolution? Effectively, a contribution, a form of data center actually in orbit. What's your view on this?
Yes, nowadays the satellite manufacturers can put a lot of processing power to the satellite. So this brings there is some processing power in the satellite. So some satellites are acting like semi data centers, but I think that it will be a limited part of it, because every appliance, every say that manufactured small appliances producing a lot of data. So processing this data needs a big processing power, especially when you combine it with the machine learning or deep learning, because you get the most of the big data by using the machine learning and big deep learning algorithms. You need a huge set of processing power. In fact, nowadays we are doing it not in the CPUs, in the GPUs. So eventually, whatever it is, LEOs, MEOs, or GEOs, LEOs seems to be a promising technology, but still there are some concerns related with it. But eventually, you will need very powerful data centers at the end to process the big data and give valuable results, highly valuable results to your customers.
Yes, thank you. There's another interesting area that I'd like to touch on now, because it strikes me that the previously very rigid and fixed boundary between satellite communications and Earth observation, Earth observation data is actually changing, and particularly with new low Earth orbiting Earth observation infrastructure and the amount of data that they generate, data that is valuable to many customers in terms of its contribution to the kind of actionable intelligence you were talking about earlier on. Now, do you think there is a major market about to step before the industry in terms of parts between Earth observation and the global satellite communications infrastructure, combined with ever more sophisticated data analytics, and that teleports can clearly integrate together, dealing with a lot more observation related data? Do you think this is an important future prospect?
Martin, I lost your voice and cannot understand all your sentences, but I think you're asking that is satellite communications and Earth observation still has the advantages part of the existing advancements in the satellite industry. And I say that yes, because especially the Earth observation is producing a lot of big data. The high definition images sent by the LEO satellites are, I think, maybe zettabytes, has zettabytes of volume. So it is almost impossible to go through all these satellite images using the humans. So you will need, anyhow, you will need not just maybe the machine learning, but deep learning algorithms to process all these data and come up with the actionable insights related with the Earth observation. So I think that the Earth observation for a long time from now on will continue for the driving force for the using the big data, machine learning, and deep learning algorithms, including with the big data analytics in the satellite industry. So it will be the number one area, I think. But of course, there are other areas related with the big data and machine learning algorithms in satellite industry. But it will continue to be number one. Of course, in
Okay,
my
thank
opinion.
you very much. Thank you. Now, I am advised that because of a technical connection issue uh, for Suleiman's location that seems it is not possible to resolve, though I have many, many other questions, and I've enjoyed talking to you for the limited time that we've had so far, gentlemen. I have been asked by the organisers to conclude the webinar at this point. Thank you for your respective contributions. It has been interesting. As I said, I had many more questions, and I had hoped that the conversation would go on for at least another 10 to 15 minutes. But unfortunately, circumstances dictate otherwise. So with that, I'd like to thank you both for your time and for your insights, and stay safe. And I wish you all the best. And goodbye for today. Goodbye.
Thank you, Martin. Thank you, Martin. Thank you, Suleiman.
Goodbye. Thank you, Mr. Hakan.
Thank you.
Hello, Houston, you're good in 1 minute. Apollo 11, this is Houston. You are go for TLI, over. Apollo 11, thank you.